For the question 1, we are given a random sample of 42 UN graduates, and we know that the average time before promotion is 5.5 years with a sample standard deviation of 1.1 year. And we need to estimate 99% confidence interval for the true population mean. Since the sample size is larger than 13, so we use the central limit theorems, which allows us to approximate the distribution of the sample means as normal. Therefore, we use the zig distribution for this calculation, and the formula like the slide show that means plus or minus z times standard deviations divided by square root of n, and we substitute the data into the formula, and we get 5.5 plus of minus 2.58 times 1.1 divided by square root of 42, and we get the upper limit and lower limit, which is confidence interval for the population means is between 5.062 to 5.938 years. For question 2a, null hypothesis is which is H0 is a statement about the value of a population parameter developed for the purpose of testing numerical evidence. Well, the alternative hypothesis is statement that is accepted if the sample data provide sufficient evidence that the null hypothesis is false. For question 2b, one tail test is test for an effect in one direction, for example, greater than or less than. The rejection region is in one tail for distributions. Well, the two-tail test is test for an effect in both directions. For example, not equal to. The rejection region is split between both tail of the distribution. For question 2c, p-value is the probability of observing a sample value as extreme as of more extreme than the value observed given that null hypothesis is true. For question 2D, we will walk through the hypothesis testing process step by step to solve the problem. First, we will state the null hypothesis, which is H0 indicate means equals 6.6, and the alternative hypothesis, which is H1 indicate means not equal to 6.6. And step 2, we note that the level of significance is 5%, which we write that is alpha equals 0.05. And we go to the step 3, we decided to use the distributions since the sample deviation is unknown. And we go to the step 4, we need to formulate the decision rule, and we know that the degree of freedom based on equation is 6, which is we get from 7 minus 1, and we can find the critical t-value from the t-table, and we get that the critical t-value is 2.447. And next, because of the symbol are not equal to are used in the step 1 for H1, so it is indicate to the two-tail test. So the rejection region is split between both tails of distributions, and we will write that the decisions that reject H0 if compute T greater than 2.447, and reject H0 if compute T less than negative 2.447. And the most important in the step 4 is we need to draw the normal distribution diagram and label two sides left and right with the critical t-value are fine. And in the step 5, we will calculate the statistic, which we get the means equals 7.557, and the standard deviation equals to 1.177. And next we will compute the t statistic when we get the means and standard deviations. And last we get t equals to 2.151, and we can make a conclusion, which is 2.151 fall outside area of rejections and do not reject H0. And we can conclude that the statistic significant change in average wage of birth at the 5th level of significance. For question 3a, to perform hypothesis testing, we need the 5 steps, which is first, we need stage the null hypothesis, which is H0, and the alternative hypothesis, which is H1. And step 2, we need to select the level of significance. And next, we need identify the test statistic. And step 4 is we need formulated the decision root. And the last, we need compute the t statistic and make a decisions and interpret the decisions.
For question 3b, the sample of the fast food is 6 and the sample of the restaurant is 7, so the DF value is 11. The X bar of fast food is 855 divided by 6 equal to 142.5, and X bar of restaurant is 912 divided by 7 equal to 130.286. Sample standard deviation of fast food is 12.2434 and sample standard deviation restaurant is 15.7873. So for step 1, the null hypothesis is mu sub fast food less than or equal to mu sub restaurant. The alternate hypothesis is mu sub fast food greater than mu sub restaurant. For step 2, the significance level is 0.1. For step 3, we use t distribution. For step 4, reject H sub 0 if computed t greater than 1.363. The breakdown area is the rejection area. For step 5 is S squared sub p equal to 204.09. So the t value is 1.537. So 1.537 falls inside the rejection area. Reject H sub 0. We conclude that the mean salary are greater for the fast food workers than the restaurant workers. The p-value is between 5% to 10%. For question 4a, the difference between post-training survey and pre-training survey for customer A is 2, customer B is 0, customer C is 0, customer D is 3, customer E is 2, customer F is 1, and customer G is 6. For the D bar is the sum of the difference divided by number of the sample. So equal to 14 divided by 7 equal to 2. For the step 1, the null hypothesis is mu sub D less than or equal to 0. The alternate hypothesis is u sub D greater than 0. For step 2, the significance level is 0.05. Step 3, use the t distribution. Step 4, reject H sub 0 if computed t greater than 1.943. The breakdown area is the rejection area. For the step 5, S sub D is equal to 2.0817 and the t value is D bar divided by S sub D divided by square root of n. So equal to 2.542. So 2.542 falls inside the rejection area. Reject H sub 0. We conclude that the training was effective in improving customer relationships. For question 4b, A, the DF treatment is k minus 1 equal to 2, so k equal to 3. 3 treatments are there. B, the DF total is n minus 1 equal to 11, so the n is equal to 12. Total sample size is 12. C, the DF total is n minus k, that is 12 minus 3 equal to 9. The DF numerator is 2, the DF denominator is 9, the significance level is 0.05. So we can refer the table of the critical value of F distribution. So the critical value of F is 4.26. D, the null hypothesis is mu sub 1 equal to mu sub 2 equal to mu sub 3. The alternate hypothesis is the means are not all equal. For E, we should complete the ANOVA table. The DF value for error is 9, so we can calculate the sum of square for error. That is 9 times 20 equal to 180. Next, we can find the sum of square for treatment, which is sum of square for total minus sum of square for error. 500 minus 180 equal to 320. For third, we can find the mean square for treatment, which is sum of square for treatment divided by k minus 1. That is 320 divided by 2 equal to 160. For the last, we can find the F value. That is mean square for treatment divided by mean square for error. That is 160 divided by 20 equal to 8. So 8 falls inside the rejection area, reject H sub 0. We conclude that the means are not all equal. For question 4c, the step 1 is null hypothesis is mu sub ghost equal to mu sub jet rat equal to mu sub croton. The alternate hypothesis is the means are not all equal. Step 2, the significance level is 0.05. Step 3, use F statistic. The numerator is 2 and the denominator is 32. We can find the F value is 3.3. For step 4, reject H sub 0 if computed F greater than 3.3. The breakout area is the rejection area. For step 5, we can find the DF total, which is n minus 1 equal to 34. The SS total is 796.971 and the SS error is 669.857. We get the answer for SS treatment, which is 127.114, which is SS total minus SS error. So the MS treatment is 63.557 and MS error is 20.933. The F value is 3.04. So the 3.04 falls outside the rejection area, do not reject H sub 0. We conclude that there is a difference in the mean flight time among the three airlines.